I'm going to do an overview, technical overview of the implementation of the game I have made for low-res jam. It's a game jam that occurred in August of this year, and I sent a game called MEMO CART, which you can play if you want. So it's using WebGL, and it has been a great exploration of this paradigm that allows to draw things with just a distance estimation function. So it's a remarching sign distance function. And I've made some cool audio as well using Web Audio API. And so there are some interesting features I've used in terms of architecture of my project. So first of all, I'm using React. I'm using Create React app to just quickly bootstrap my project. And then basically I have so I'm going to cut the sound for a bit. So I have a main component here that just renders the game basically, but so because there is an UI, there is this menu that I'm just using React for, but basically otherwise the other part is made with Canvas and WebGL. But the main idea of my architecture is that there is just a big game state that is just a variable here, but basically my render component here that will render the WebGL just have a way to get the game state and just have an action function. So for instance, the tick that occurs at 60 frames per second is a function that takes the game state and it returns a new game state. And each time there is a tick, I go through all this function, the tick function, and like completely create a new game state. But it's a shallow copy, so it's not so costly. So we will try to see all of that. Let's start with the render here. Let's go into it. So I'm rendering a canvas here, and I'm initializing everything in when the component did mount, and I'm using REGL, which is just a thin wrapper for doing WebGL, and that's not so much code here, but basically I'm rendering my shader. I have a few other shaders to do some persistence effect to have like motion blur basically. I have other thing here, like I'm generating a Perlin noise just to have a nice, so it's like a texture which is not really pure random, but which have some pattern, and it's interesting to just generate the like the granularity of the walls and some texture in the game as well. So yeah, I also handle events here, of course. So yeah, basic event handling. And what's interesting here is I'm also using, so I'm using Webpack, and I'm using hot reload of Webpack, which allows me to hot reload my shaders and also hot reload my logic. So let's see how it works. I just have module.hot accept, and I just accept each time this change. I will just inject again the render function, and so that's where my shader is implemented. Let's see. So yeah, again, my game is rendered with a big shader that just draws everything in this paradigm that just allows me to define there's a scene function somewhere. Hold on. Yeah. So this is the main function, the main entry point basically, and the contract is that I take any point in the in space, so any 3D point, and I will give you back the distance of the closest object. So it's in the first, the X component, and in the Y I will have the material ID. So whatever object matched will be the identifier of that object. So for instance the cart, for instance the rail, for instance whatever. And then with this material ID I can give the color. So I have another function here that just gives the RGB color for a given material. I also have some other information, like in which biome you are, because I want to colorize things differently, like the rails will go black in some biomes. So yeah, it's quite I mean, it's a simple concept at the beginning. It's just adding up more things into it, but it's not so tricky. But basically how it works with this distance function is using a remarche technique. So it's a simple approach that just will throw rays, like from your eye you throw rays for all pixels, and for each ray you will do a lot of loop in this for loop, and you will try to progress a bit until you reach a distance, a small distance. So you progress with the distance that my scene distance estimation function will tell, and when it finally reaches the object, which means the distance is nearly 0, then we are done. We can just return the distance because we will need for other things, and we can give the material as well. Why do we return the distance? Is because we also want to know the point, so we compute the point that matched the object, and with that point we can compute the normal. So normal is a vector that point in the direction opposite to like orthonormal to the surface, and with that you can do nice lightning. So basically when the light is like orthonormal to the face, it's lighter, and when it's whatever. I mean, you get the concept, I think. And you can also do interesting things like specular, which I use on the cart, which is just this kind of reflecting effect. So anyway, also what I have in this in the development mode is some debug information here you can see, and I can, for instance, disable the UI, which is implemented in Canvas, by the way, in Canvas 2D. I can stop the speed. I can also give a free control, and here I have my controller, Xbox controller. Let me plug in it, and with my controller I can move the. I mean, I can also use the mouse here, like I'm doing here. I mean, you just want something like this to, when you develop, to see what you are doing, and like in a more closer look, like zoom into things. You also have a way to increase the resolution, but it's quite slow. So yeah, that's kind of it for this part. So yeah, it's interesting to have such thing. Also for the for the level design, I have a function that allows me to generate a map, and it will just tell me all the biomes that will be in the levels. and I was just using that to quickly generate the, like improve the generator. So that's, I don't want to go into much detail for the rendering part for now in this video, but now I will just take a look at the logic part that just rules the whole game. So, as I said, everything is defined in some functions that take game states and return a new game state, basically. And it's first created in the, so it's, I mean, there's only one state, which is in this main entry component, and that's the game state object. And there's this action function that anyone can call, but just modifies the game state in place, which means everything else under this main root component and everything under it can just be auto-loaded without any problem. So, I mean, I can prove that to you. Like, I can change code on the fly. Like, let's do something on the color, for instance. I save. So it takes some seconds to actually compile this shader because it's quite intensive, but at the beginning it was quite useful, and it was because it was very fast. And I mean, I could even disable some part of the code. Or for instance, if I load the game in low mode, it's much faster because it doesn't use any normal map, and the normal function is quite intense because there is like 6 lookup of the scene function, and the low version just will bypass any normal computation. So yeah, I can reload things. It's quite interesting. I can, like in my scene, I will be able to comment out some objects, for instance. Like, let's say I don't render any cards. I comment that, and I have an instant like feedback of what I'm doing, and it's, I mean, super useful. So yeah, anyway, there's a lot of cool things to do when you have hot reload, because for instance, you are in a given configuration at a given place in your world, like in the given game state, and you want just to keep the game state and just see how it, I mean, continue developing your scene while having the same game state, especially when you investigate bugs. It's quite useful. Save a lot of hours. So yeah, let's undo that. I just reverse the color. Come on, help me, Git. And so the logic part. So the game is created with the create function. A game state is created with this create function. And then everything will go through the tick function. I have used some flow types just to, I mean, to have my mind like happy about my types, and just to quickly see when something is wrong. Like you are trying to access a non-existing field, or it's quite useful. But basically, so this is my game state. There's a lot of things I like. Yeah, over time I have added a lot of things, and especially there is one part which is for the UI. So the whole UI is also defined in this state, and the UI is just like, do I have a logo, do I have a title, a footer, and there is a string, which is a text. There is also a state for the audio itself. So yeah, there is some audio in the game, and it's kind of like it's a baked version of that. It's like there's some duplication because you could recompute probably from the game state, or it's more an accumulated version of the game state, but it's just a quick way so I could just have a turn shake factor, a descent shake factor, so like how many delta you change. So I can increase some sound based on that, based on the braking, based on the speed. I have some booleans to trigger a given sound, and everything is set with inside the ticks. So yeah, tick is everything basically. What's interesting about how I represent my world is that my world is a chunk of. Oh, wait, stop the world. My world is a chunk of some tracks, and each track, have a turn, have a descent, but that's basically it. And also there is some biome. There is a biome 1, biome 2, and a biome mix, which allows me to nicely fade between biomes. There is also a seed, and that's basically it. That's what a track is. And so there's a chunk of tracks, which is just 12 at the moment, I think. There's 12 tracks that just rotate. Not rotate, but I remove the one before your position, and I add up one at the end, and it happens each speed time. It depends on the speed, but that's how it works, and it's quite efficient that way. So it's like a window of track that move forward when you progress. So if I look behind me, there is nothing. There is a dark wall because I've made that says, the scene function should not go farther than that. There's no point looking backwards, so I can just return black and shortcut the computation. It's the same in the front of the tracks. There is no point to go farther than that, so I just return black. And if I progress, you can see it jumps. So to avoid visually seeing these jumps, what I did is that I have also a progress value from 0 to 1, and I can interpolate everything based on that, like the cart position, and I can also interpolate the curve of the descent and the turns. That way it's like seamless, and same for the walls. Everything is seamless. It was not so easy to figure out the formula, and they are not so right. They should have been better, especially the way I implemented the turns. It's not real rotations. It's actually just a delta, like a turn. If you turn left, is just moving the pixel left. The ray will go left and won't turn. It's not a turn, it's more like X offset. So if you try to turn a lot, there will be a visual bug. It won't look good, but it's a game, it's not a physics thing, so it's okay. I didn't figure out the proper physics to do, like, if I really want to implement a rotation. I think it will be great to figure this out if you want to do like some spin, like I don't know you call that, but it turns a few, it do a few turns. It will be interesting, like a rail coaster. Yeah. So anyway, that's not my game, so just took the simplest solution. So this track array is actually sent to my render function, to my shader, as a texture. So it's a 12 by 1 image, a texture where RGBA is used to encode everything. It's crazy, but it works. And so, as I said, my track field here don't change all the time. So I keep returning the same array, and that way in my render function I can just update my texture when it really changes. Like, no, it's not, sorry, it's not here, it's here in the component. So I just do this. If track change, then I can re-encode the array and upload the texture to the GPU. And the encoding is something like this. So I really try to push everything into a color and using every possible bytes, which was quite tricky because I wanted to send more information, but at the end it's okay. And I have also an alternative track which I use for the intersection. And that's it. I mean, also there is a UI that draws on the canvas using a canvas 2D and injecting as a texture as well. So yeah, not enough detail. Let's see how the tick function do some work. Maybe it can be interesting. So this is the tick function. Takes the previous state, return a new state. There's also some events information I have, like the time, the tick, the user events. So there is one part handling the tutorial. There is one part handling so this is just for debugging, the control. Then there is this part that will handle the events. So braking, going left or right. So I split based on the level because the level will have different behavior. Like the demo is not controlled by the player, but by some kind of bot. Simple AI that just do math random. So that's it on this events handling. Then I have this huge if here that will just enter each time there is a new track reached. So each time you go one step in the track, I will have to create a new track. And that's where the nice part and a lot of work has been made is on the generating of the levels, on level design. That's the Jane track function that take the index of the track, a seed. So a seed is a string that just is unique for the whole game. Pair run or pair whatever. I mean, actually my game have limited levels because I want it to be limited so I can have people playing on the same maps and having high scores, but everything is in a seed, is generating from a seed, so that's it. And it's really like I can call it twice, it will be the same result. It's deterministic, so it's quite interesting for debugging, for many things. And I can cache this value as well, I can memorize. So yeah, the gen track is quite interesting. And there's a lot of math going on here, there's a lot of cosinus, a lot of cosine, a lot of trigonometry. And I'm using seed random, which is a library to do math random, but in a seeded way. So I just initialize with some string and give me a function that I can call and give me a number between 0 and 1, and that way I can do some random decision that are deterministic. And yeah, that's it. A lot of logic here, depending on the biomes. This track also will contain the biome information, and there is the gen biome to generate, so there is like each 22 track there will be a new biome, and I have to figure out what the biome is, and I even do some logic, like if there's two intersections, I will try to use, I will use a void between the two. It's likely to happen, so it's not always happening, but a void is just kind of like an intersection, except there is no intersection, but it's the same biome where there is no walls, you are in total void, and it's quite interesting to have them it's like close to each other. It gives a nice touch and less random. You don't want like your levels to look random. You want them to look a bit more design. So that's where you want to add up some work to avoid that. All right. So yeah, that's the game logic here, but the point is I'm never altering anything on the initial, on the previous game state. I'm just creating a whole new game state, and my render function will just take a game state. That way, what's cool is I can change any game state, and it will be instantly hot reloaded. So the speed, I just stop the speed by setting jitter speed equals 0. I can put 10, I can put 100, I don't know. So it's super useful, because you are developing your logic and you just want to keep the current state you are on to just experiment things, and like the way the gravity happens, the way the speed is accumulating, here. So I have acceleration, I have speed, and I just want to tweak some values. So let's see if I just do that. If I do that, for instance, so I've just made the speed to just like stops very fast with a lot of frictions. That's not good, but just to show. So if I break in the game, it will be instantly breaking. Anyway, so that's quite useful. And so I'm not sure what I want to cover more here. There's a lot of details to go through. I could, but it will take a lot of time. That's it for the tick, basically. As I said, my tick also will accumulate some values for the audio states, and my audio is in the same, kind of like I have a render function that takes the game state and just renders the game. I have an audio function that takes a game state and like process the audio or apply the game state on the audio. And it's more an audio state, which is a subset of my game state, just with the information I want. And my audio exposes this function as a sync function that just takes this object and will tweak some value on the audio. I have a lot of loops, audio loops, that just play the sound forever and repeat forever, loop forever. For all biomes, basically. For the track, for the cart, the cart. When it descends, you have a specific sound for when it goes up and down, and you have another specific sound for when it goes left and right, which is like scratching, like kind of like you turn. So I'm just changing the gain based on the turn check. I'm also playing with the playback rate, which allows to speed up or slow down the sound, and it's usually function of the speed of the cart. So when you don't move, there is no sound. When you start moving, it starts to like speed up the sound. So it's nice trick. I don't know if I can quickly show that, but one issue I have is I have not implemented any hot reload. It doesn't support hot reload because Web Audio API have a state, and I mean, I think it's possible, but you just will have to split this into two pieces, like keeping all your audio nodes in some place, and just just putting that sync function in another file that will get hot reload. It's possible. I just didn't made it this time, but I will try next time because I think it's quite interesting as well to have hot reload of this. What else? I don't know. Anyway, if you have any questions on one part you want me to cover, I can do that. There is a lot of things. I had a lot of fun. So yeah, I don't know. I don't want to go more into details because it will be too boring maybe. So that's it. If you have any question, feel free to ask me and on Twitter, or I can even do another video if it's interesting, or an article, whatever. Anyway, thanks a lot.